I'm experimenting with Couchbase Spatial performance. I've installed Couchbase Community Edition 4.0 on a Windows Server 2012. It's in a single node with a single bucket, and that bucket is a large data set with geometry. So what I'm doing is I'm attempting to get a feel for Couchbase's spatial performance on large data sets. The data set I'm performing these tests on are contour lines. This is complex geometry. So I built a quick interface using Google Maps to display the data through a separate service that I built. My service queries Couchbase, which returns the data to my app. I did this because of CORE's cross-origin resource sharing requirements. My service essentially proxies. So first, I started by simply converting the spatial data format to GeoJSON, as it's the only compatible version with Couchbase at the current revision. With complex geometry, I quickly learned that even though Couchbase handles the objects like a champ, creating a spatial view on the geometry with over 1,000 points for any given record meant slow indexing and huge returns. Some of my indexing was taking somewhere between 10-15 minutes, and at one point almost half an hour as I got to 300,000 records. So $20 to 30-second returns for that kind of data is not bad. It's pretty good considering the amount of geometry. But I know 10-20 megabytes for any return would be slower to the outside world. So if I ever were to publish something like this, you'd have to take that into account. It would be some time for the data to return. Even if Couchbase returns it quickly, you still have to essentially download it. So what I did is I turned to Google's geometry encoding to reduce the amount of data that would be returning. I encoded each geometry and stored it into the service and rely on Google to parsing the data. But because Couch still needs GeoJSON, I created a bounding box that stored that for the view. I have a simple square polygon being indexed as a sort of a bounding box of the geometry that I'm stored, and then separate from that is the encoded. So here's a return that I was getting before. So as you can see, I mean, this is not that many records. It's just, but it is very large. And to give you an idea, let's see. So this is a similar return now. This is far more records, but as you can see, I've encapsulated stuff so you don't see tons of geometry floating around. So here's the problem. Here's the rub, right? When using Google polyline encoding, you're sacrificing accuracy. As you can see by this, I had fairly accurate points. These contour lines are 2-foot contours, and when you convert things when you use the Google's polygon conversion, you essentially, let's see if I can find the document here. So this point right here, where you end up multiplying the decimal, you're going to end up losing some accuracy, right? And obviously it's because, one, Google doesn't really care about that accuracy, as WebMercator is not that accurate anyway of a projection. But in this case, you can clearly see some of the inaccuracies. So if I were to load some data and zoom in over here, these jagged lines are not really supposed to be jagged, and you see strange artifacts because of the inaccuracies. You can also get lines crossing over each other, which is, not possible in Contour. But for this demonstration, it's, pretty straightforward. It's tolerable. So, because well, these points, my original data, the points were created through LiDAR, so that's extremely accurate. And as I'm taking away the accuracy, you get a little bit more of this. However, my goal here is not necessarily to test the accuracy of my points. It's more of testing the speed at which Couchbase is returning my data. So now that I've got my data encoded, encapsulated inside my service, each time I pan around, this thing is doing a select. And with currently sitting at 106,000 records, the performance at this zoom level is fairly quick. So if I zoom out a little bit and do the same, and this is returning vast amounts of data. But as you can see, it is returning these large data sets and drawing them on the map. If we were to pull up the inspector here, click over to network. Let's fix this a little bit. Let's go ahead and pardon me for a second. Let's clear that so I can do a fresh one. So the service returned in 3.27 seconds, which returned a large data set. So I'm pretty happy with the way it turned out. I will continue to tweak and see if I can increase performance, but for a single node, I'd say that's not too bad. All right. Well, thank you for your time. I appreciate you watching the video. Happy coding.